Our lives depend on a handful of natural resources. But they're not the ones you think they are. Forget oil, coal and gas. Today we depend on a new set of super elements with obscure names like indium and rhenium. Their properties are so bizarre they may as well be alien technology.
There's not a scratch on it. Hotter, hotter, no problem whatsoever.
These super elements are driving innovation, everything from smartphones to MRI scanners.
That's the magic stuff.
But there's a problem. They're rare, and they're already running out. The stuff that makes smartphones work could be gone in a decade. The mineral we rely on to feed the world is mostly found in just one country. We are reaching the limits of what our planet can provide. We can't rely on recycling to rescue us. To fix the future, we might have to mine in space.
We'll be able to do it in the next 10 or 20 years.
So in my lifetime,
Yeah.
we could be mining space.
Yeah.
So what are these super elements? Why do we need them so badly? And what can we do to save them? There is one object that contains more super elements than almost any other. The smartphone. 1 billion were sold last year. There are phones, our cameras, our sat-navs, our notebooks, our diaries. You can watch a film on them, you can book a flight on them, you can check your bank balance on them, you can even film a whole BBC documentary on them. But for a material scientist like me, it's what's inside these smartphones that's so impressive. To prove just how good super elements have made our phones, we're going to film this program on one. There's a lot of amazing stuff in a smartphone, but I'm going to reveal what I think is the single most important ingredient in our phones. It's in every single smartphone, it's essential to how they work, and yet I'll guarantee you've never heard of it. First, I've got to get into one, and that's surprisingly difficult. So I've equipped myself with a range of precision tools. The question is, which one will get me inside the phone? They're not really designed to be taken apart though. This, however, will really do the trick. Quite slippery these things. Hold on. Now, there we go. Microphone. Look at all these little processors doing all the processing of your speech. There's loads of different metals inside. Silver, copper and platinum to start with. But that's not all. That's what I'm after there. That's gold. There's 300 times more gold in a kilo of smartphones than a kilo of gold ore. Your average smartphone contains over half the elements on the planet. There's lithium and cobalt in the battery, lanthanum and yttrium in the screen, terbium and dysprosium make the microphone. There's even arsenic in the silicon chip. Each element has a unique role to play, making our phones slimmer, smarter and more powerful. But one stands out from the rest. A rare metal with a magical property. To understand how critical it is, cast your mind back to what phones used to look like. Bricks covered in buttons. The phones got smaller and smarter, and some of them could even connect to the internet.
But they still needed a keyboard, and that limited their powers. Then some clever scientists discovered the superpowers of an element called indium.
And here it is, indium. Now, one of the tricks for understanding this metal is to have a bite, because it's so soft you can chew it. I mean, not a good substitute for chewing gum, but nevertheless, an amazing thing, but not as amazing as what I'm about to show you. If I take indium and I do this, watch what happens.
Amazingly, it can turn into a liquid. But that's just the start of indium's weird and wonderful properties.
Now, if I take this liquid, I ought to be able to paint a line on this piece of paper. I've got a light bulb here, and there's two wires connecting it to this power source. And when there's a circuit, then the light comes on. And the question is, will this liquid metal that I've just created conduct electricity? And the answer is yes! Brilliant.
So we have a soft metal that can turn into a liquid that conducts electricity. Not bad. But it has one more astonishing property. The thing that makes it an absolutely vital part of every smartphone. Mix it with tin and oxygen and you get indium tin oxide, a transparent electrical conductor. And that's how you make the touchscreen. They appear so simple, even a toddler can master them. But touchscreens are revolutionary.
Before touchscreens, it was hard for smartphones to be as complex as computers because you had to fit lots of tiny buttons into a small space. But with a touchscreen, your finger is a keyboard and a mouse in one. And so the whole screen is able to control something as complex as a computer.
And I can just scroll around like this.
The screen itself is a conductor, and so is human skin. It works like magic. 10 years ago, Apple exploited indium's incredible properties to create the first touchscreen phone you could control with your finger.
And we are calling it iPhone.
The smartphone as we know it was born. An entire new industry was created. But although the touchscreen had solved one problem, it had created a new one. Demand for indium soared, and it's not that easy to get hold of. In nature, indium is found tightly bound to other metals, most commonly zinc. To coax it out of zinc ore, you have to dissolve the rock in acid, then bake the acid in a furnace, then mix a precise cocktail of other chemicals to finally extract a minuscule amount of pure indium. Touchscreen technology has become critical to our economy. The app industry alone earns more money than the Hollywood box office. But if you do the maths, you find a problem.
There's only a tiny sprinkling of indium in every smartphone, approximately 0.02 grams. But we buy 1 billion smartphones a year. That's a big number. If we add in all the other uses of indium, like tablets, other flat screen devices, and all the other electronics that use indium, we get a number of 700 tons of indium that we need every year. But in 2008, the US Geological Survey estimated that there was 16,000 tons available. Now, if that was right, at the rate of 700 tons per year, we would be running out of indium in the next decade.
Then again, maybe not, because as it gets scarce, the price goes up, and that encourages companies to go out looking for more. The problem is that takes time. And it's a bottleneck that could be the stuff of nightmares. Imagine young people of the future, unable to have phones. Unthinkable. Indium isn't the only element that has superpowers. In fact, I think we're living through a revolution. We're uncovering the superpowers of ever more rare and unusual ingredients. And they have changed virtually all aspects of our lives. They've even helped make our holidays more affordable.
The first time I went on a flight, it was 1977. I was 8 years old. I was with my family. We were on holiday to the Greek island of Crete. It was great. It was the first time I experienced a really genuinely sunny beach holiday. But the flights cost my parents a small fortune. I mean, flying anywhere in those days was really expensive. Now I can fly to Crete for less than the cost of a tank of petrol. Lots of factors have contributed to cheaper air travel. Changes in government taxes, more competition between airlines. But a big part of it is down to this material, rhenium. I know it looks really dull, but it's one of the rarest, most expensive elements on the planet. This piece alone is worth £100.
Rhenium is a relatively recent addition to the periodic table. It was discovered in 1925 by the brilliant German chemist Ida Nodak. The new element was incredibly tough and durable, but it also had a superpower that would one day lead to cheaper air travel for all of us. To demonstrate what rhenium can do, I've invited a group of volunteers to bring an object that's very precious to them up to the roof of this tall building.
All right, now tell me about this ring.
That's from New York, in Tiffany's.
Whoa.
Yeah.
Did someone special give it to you?
Yeah, her dad.
Oh.
I'm going to dangle the ring off the roof over the water and then burn the wire with a blowtorch.
Are you getting nervous about this ring?
Yeah.
Because I'm doing it. 5 stories up. It's going red hot. Getting white hot.
Carrie, stop it! Carrie, stop him! Carrie, stop him!
Oh my God, no problem whatsoever. Isn't that amazing?
Rhenium's superpower is heat resistance. This stuff is phenomenal. You could plunge it into molten steel and it wouldn't melt. You could chuck it into a volcano and pull it out unscathed. It's like alien technology. And its powers haven't gone unnoticed. Over 70% of the rhenium mined each year is used to make jet engines. Much of it ends up in Derby at the home of Rolls-Royce. They make the most high-tech aircraft engines in the world. And at the heart of each engine lies a disc of small but extraordinary turbine blades.
This little blade has to withstand extreme temperature and stress, and no ordinary metal is up to the job. It's made of a special alloy with over 10 different elements, but one of those is named in the industry as magic dust, and that's rhenium.
Aircraft engines work by sucking in air, compressing it, and then exploding it with fuel to create a ferocious gas jet. The jet hits the disc of turbine blades head on, heating them to over 1,000 degrees and spinning them at 10,000 revolutions per minute. The blades turn the compressors, generating thrust. No ordinary material could withstand such an extreme environment. But the turbine blades take these conditions in their stride. Rhenium's astonishing properties allow engines to operate at extremely high temperatures. And that means you get maximum thrust for minimum fuel. Rhenium saves each plane millions of pounds per year in fuel, and some of that saving filters down to us.
Fuel efficiency is one of the main reasons why flights are cheaper today than when I was a kid. I mean, rhenium has helped cut emissions and make flights more affordable. It's not a dull, boring metal. Its superhero properties make it extremely precious. So where do we get this material with such extraordinary properties? The rubbish.
More precisely, it's a waste product from copper mining. They used to just chuck it away. Chile has most of the world's copper, so they also produce most of the world's rhenium. But it's such a rare element, a ton of copper ore contains just half a gram of rhenium. All the rhenium mined in a year would fit in your living room. By exploiting rhenium's superpowers, planes burn less fuel. And that's better for us and the planet. But by solving one problem, we've created another. We've got used to cheaper air travel. We love it. As the price falls, demand rises. So although our planes are fuel efficient, we're still burning a lot of fuel. And no matter how advanced we make our jet engines, they rely on an ancient principle. Burning fuel to release energy. Our cave-dwelling ancestors first learned how to exploit fire, and we've been burning stuff ever since. More and more and more of it to meet our energy needs. It's polluting and it's causing climate change. If there's one process that's desperately in need of a super element, it's the production of energy. The answer could lie in magnets. Not just any magnets, magnets made from a super element. To demonstrate their phenomenal strength, I need some volunteers and an audience. So I've taken over a corner at the Bristol Science Centre. I'm going to see if I can amaze them with my super magnets. First up, an ordinary magnet.
I need a volunteer to do a tug of war with me. What's your name? Brianna. Nice to meet you. Put on your fridge, a frig magnet. Okay, ready? 3, 2, 1. Okay.
No problem.
The special neodymium magnet.
Next, a magnet made from a super element.
1. Yes.
No chance.
It's one strong magnet. How strong though?
Now the ultimate test. Will it hold my weight?
What do you think? Okay. Whoa. Oh.
I've reached the limit of the little magnet's strength.
That was your fault, you guys.
But if we use larger super magnets,
Got like a wild animal in this box, right?
we can even defy gravity.
Oh yeah, that's a good idea. Okay, hand on. Ooh. And how are we doing? You're levitating, man. How does that feel? Yeah. Okay.
The super element in these magnets is called neodymium. It makes the strongest permanent magnets known. And if you're wondering what this all has to do with generating electricity, it's simple. you spin a magnet inside a coil of wire, you generate an electric current. Michael Faraday first discovered this in 1831. And ever since, we've been burning stuff to drive the turbines that make the magnets spin. Oil, coal, gas, you name it. To try to reduce the amount of stuff we burn, we've come up with new ways to spin the magnets, like wind turbines. This is the UK's largest onshore wind farm. The 215 turbines generate enough electricity to power 300,000 homes. But keeping the mighty blades turning can be a problem. These complex machines are prone to breaking down.
We're out here, it's a wild, and the weather can be extreme. It's quite extreme today, actually. And having a simple thing that you don't need to come out and repair, that is a big deal, right?
That's right. And as you know, we're increasingly putting our wind turbines offshore. And so where we can make things more reliable, where we can stop things from failing in the first place, means that we don't need to stop the turbines to go and fix them.
The weakest link is the gearbox. A complex set of cogs that steps up the slow rotational speed of the blades so it's fast enough to generate maximum electricity. The gearbox has to be replaced more frequently than any other part of the turbine.
So how are new materials revolutionising the design of turbines then?
So in that generator, we're now starting to use some of the neodymium magnets. And those are magnets which are really compact, dense sources of the magnetic field. They're able to produce the field in a compact way. They're able to do it in a very efficient way.
Yeah.
And they're actually, which is really important, they're able to do it in a really reliable way.
Neodymium magnets are so powerful they can generate an enormous electrical current even at slow rotational speeds. This means the turbine blades can drive the generator directly. There's no need for a gearbox. The turbine is more efficient and less prone to break down.
I've got this neodymium magnet here. So what we're saying is that in the future, wind turbines are going to have a big hunk of this up there, right?
In fact, quite a few hunks. A big wind turbine might use 100 of these in just one part of the machine.
Wind turbines create clean energy without the need to burn stuff. But once again, solving one problem leads to another. It's not always windy, so we need a way to store surplus energy from the windy days. The answer could lie in another super element: lithium.
This is lithium. First discovered in 1817, it's the third element of the periodic table, and it has unique electrochemical properties that make it great for batteries. And when it comes to energy storage, this stuff is a game changer.
In the Nevada desert, construction of the world's largest factory is nearing completion. It will make just one thing: lithium batteries for Tesla electric cars. Lithium is light, so you can make a powerful battery that doesn't weigh a ton. The same technology is now being developed to store energy from renewable power plants. It could solve our energy crisis. But it's a potential new bottleneck, because we're going to need an awful lot of lithium. Half of the world's lithium is found in just one place: the Salar de Uyuni salt flats in Bolivia. The problem is getting it out. Mining here is politically and environmentally controversial. But at least with lithium, we can see the problem coming. Shortages of other superelements have taken us completely by surprise. None more so than helium. Helium is famous for making balloons much more fun. But believe it or not, helium is in short supply, and it's become far more important than you might think.
So using helium for balloons is no laughing matter.
Up until the 1980s, helium stocks were mainly a concern for people who owned airships or space rockets.
Yeah, you can hold
But
that
then
now.
along came a new innovation. The MRI scanner. MRI can see inside our bodies with clarity like never before and without the need for harmful X-rays. It revolutionized the diagnosis of a range of conditions from brain injuries to cancer. And it relies on the extraordinary properties of helium. Helium is weird. For starters, it can become colder than almost anything else in the universe. Lancaster University is one of the few places with the right kit to make it that cold.
Now, we've got our helium in this tube. It's at minus 269 degrees centigrade, and that temperature is a liquid. Now, that's obviously a very cold temperature, but I'm about to make it colder still, and by doing so, welcome you into the very, very weird world of helium. Pump on now.
When helium gets really cold, strange things start to happen. First, it boils ferociously, not what you'd expect from something really cold.
It's getting colder. And colder. Wait for this though, wait. There, you see that? It went from boiling to absolute still. It is now no longer governed by the classical rules of physics. It's now governed by quantum mechanics. It's a superfluid, and they're very, very weird. Let me show you what they can do.
Superfluid helium can flow through solid materials.
I've got some more liquid helium here in a container, and it's kept in there by that stopper at the bottom, that red stuff.
I can make it pass through the solid stopper.
As I move it down towards the superfluid, it's getting colder and colder, and it's going to turn into a superfluid itself.
Watch the stopper as I lower it towards the superfluid.
There.
You see? It's dripping through a solid material. That's one of the strange properties of superfluids. They can flow through solid materials. It just seems wrong. I mean, it goes against all the kind of normal laws of physics that we kind of take for granted. It's just bonkers.
A superfluid is a liquid that flows without friction. Think of a cup of tea. Once you stop stirring, the circulation slows because of friction. But a cup of superfluid would continue circulating until the end of time. And superfluids can transfer their magic powers to other materials. Bathed in superfluid helium, some electrical conductors become superconductors.
So just as a superfluid can pass through a material with no resistance, so electricity can travel through a superconductor with no resistance. And that means no electricity gets lost.
superconducting wires deliver far more electrical energy than ordinary wires. And that's what MRI machines rely on to generate the powerful pulses of energy that I use to make images of our bodies. Each machine needs around 2,000 litres of liquid helium to keep it running. Considering that we give it away to children, you'd imagine that there's loads of it around. But helium is scarce. It's produced incredibly slowly from the radioactive decay of rocks deep underground. Over millions of years, the tiny trickle of gas builds up into large reservoirs. Algeria, Qatar, and Russia have some, and in 2016 a new reservoir was discovered in Tanzania. But most of the world's helium comes from just one place: America's Midwest. America's Great Plains sit on top of a vast natural helium store. For years, the Americans stockpiled it in a huge storage facility in Texas. During the Second World War, it was a strategic gas in airships. Later, it was used in the space race. But after that, they started selling it off cheaply. And now the world's largest helium reserve is almost empty. And to make matters worse, it's really hard to recycle.
One of helium's more obvious but less exotic properties is that it's incredibly light. That's why helium balloons float in air. But it also makes it incredibly difficult to recycle helium, because once you let go of it, well, it just keeps going up and up and up. Of course, eventually the skin will pop, but the helium will keep going up and up to the edge of the atmosphere, into space, and be gone forever.
Mind you, not all superelements are rare. Some are plentiful, but they're only found in a few places. And the countries that own them aren't always willing to share. One of these materials is wanted by almost every nation because its superhero strength is nothing short of miraculous.
This is a magic ball. What's magic about it, you might ask? Well, it's shiny, and it's smooth, and it's very spherical. But what's really extraordinary is that it's virtually indestructible. Now, to a material scientist like me, that's a red rag to a bull. I can't resist trying to destroy it. Right. I'm going to have to escalate this. Incredible! There's not a mark on it. It's absolutely pristine. This material is called tungsten carbide. It's a compound of tungsten and carbon. And it's very unusual because it's not brittle. And yet it's incredibly hard. And that's very unusual in a material. Something that won't scratch, but won't break, even under the most extreme forces.
Ever wondered how you drill through steel? Or cut a railway tunnel through solid rock? You do it with tools made from tungsten carbide. The military used loads of tungsten to armour their tanks. No other material is tough enough. But over 80% of the world's tungsten is produced by just one nation, China. They've been selling it for decades. Then, in 2010, they restricted supply, sending shockwaves around the world. But a solution has been found in a field in Devon. In 2015, the diggers moved into the first metal mine to open in the UK for 40 years. They're digging for tungsten.
Cornwall and this part of Devon are all very rich in metals. Cornwall in particular is known for its tin and copper production historically. The thing that's unique perhaps about tungsten compared to other metals is that there's not a lot of mines producing it, especially in the Western world.
That's incredibly impressive. Just what strikes you just how big the operation is. So where is the tungsten ore here then?
So the tungsten ore is contained within a granite ore body, which is the white material you can see here in front of you. And within the granite you've got hundreds of thousands of these quartz veins.
So this is a lump of quartz from one of those veins?
Correct. Every grey kind of stripe in the rock is a vein, and within those veins you've got quartz matrix, and then within it is your wolframite, and that's your tungsten ore.
So wow, so there it is. That's the magic stuff.
Correct.
And how rare is it to find quartz in kind of this vein-like structure with wolframite in it in the world? How rare is that?
It's relatively rare to find it in this kind of quantity. This is a pretty big mine by world standards, certainly one of the biggest deposits in the world. This is by far the largest concentration of it in the British Isles.
These huge diggers shift over 10,000 tonnes of ore a day. There's enough tungsten here to secure supply for at least a decade.
This is a 125-ton excavator loading a 100-ton dump truck with category 1 ore. So this is the best quality ore, and so you have enough dump trucks so that when one is full and off, there's another dump truck to take its place.
How long does it take from digging it out here to refining it and then coming out as a product?
If we took that straight into the crusher and it was immediately crushed, I think to get through the whole of the processing plant, I think is about 50 minutes.
50 minutes?
Yeah.
Wow, that's efficient.
Yeah.
The ore is crushed and then fed into the processing plant. No chemicals are used to extract the tungsten. It's so heavy they can separate it using gravity. The crushed ore is washed, filtered and shaken until the dark finished product separates out.
There you go. Put your hands in.
Wow, this is it.
So this will be about 55–60% tungsten, this.
Wow, it's really heavy.
Yeah, very heavy.
Incredible.
Each of these 1-ton sacks is worth £16,000. Tungsten is a super element because it can withstand virtually anything. There's nothing else quite like this stuff.
And now for the ultimate test. Let's find out how strong this ball really is. Could it withstand this industrial roller, or this industrial roller, or this industrial roller, or this 20-ton industrial roller? Let's see, shall we?
Just to show how effective this roller is, first let's try a cricket ball.
Yeah. No longer a ball, more a puck now.
Now the tungsten carbide ball.
The wood's destroyed. The ball, totally unscathed. That's amazing. Absolutely unscathed. Wait. Okay, look, that's what's happened. It's made a massive hole in the concrete. There's not a scratch on it. It's absolutely, completely pristine.
We have a stable supply of tungsten for the time being, but demand is rising. As it is for all our superelements, for one simple reason.
When I was born, there were 3.5 billion people on the planet. Now, there are 7 billion. The human population has doubled in my lifetime, and all those people are buying and using ever more complex stuff, and that's requiring us to dig up more and more minerals to keep up with demand.
All our superelements come out of the Earth. We're really good at finding them. So far, we haven't run out of anything. But there is only one Earth, and sooner or later, we're going to reach the limits of what it can provide. It's the ultimate bottleneck. If that happens, we can kiss goodbye to our high-tech world. So what can we do to fix the future? We could start by learning some lessons from nature. There is one superelement that nature needs in abundance, and in nature it never seems to run out. It's called phosphorus.
So they just look like little bits of wax that you might get.
I'm back with my audience in Bristol to demonstrate a stunning property of phosphorus that explains why it's so important for living things.
Okay, I'm going to go for it now. You all ready for this?
Watch what happens when I burn a tiny bit in a big jar of oxygen.
I give you phosphorus, everybody.
The phosphorus glows because it's highly reactive with oxygen. The reaction creates molecules of phosphorus bound to oxygen, and these molecules are the building blocks of life. They form the backbone of our DNA and the DNA of all living things. Phosphorus is one of nature's superelements. Plants get it from the soil and return it to the soil when they die. But when farmers harvest crops, they often have to replenish the phosphorus artificially with fertilizer. The fertilizer is made from phosphorus-rich rocks. But there aren't many of them, and we've dug most of them up already. 75% of the rock that's left is in just one country, Morocco.
You might not like to think about it, but poo makes excellent fertilizer. When we eat plants and animals, we eat the phosphate they contain, and by and large that passes straight through us. So that means that sewage is chock full of phosphate fertilizer, and the poo from the people of Nottingham is as good as any other in the world.
At this sewage treatment plant in Stoke Bardolph, human waste is something to be prized and revered.
Hi, it's the BBC here. We'd like to talk about your poo.
Okay, come through.
Although full of phosphorus, you can't just spread human poo on fields. It smells pretty bad, and it's full of deadly pathogens. Like all sewage treatment works, the main job of this plant is to turn the bad stuff into something a bit more pleasant. But here, they take it one step further.
First stage of the treatment process is to remove the big bits, the rag, things like that, and also the grit.
Blue paper, do you mean that rag?
So
Just getting the big
no. So yeah, loo paper will be trapped on the screen, and all the stuff that people throw down the toilet that they probably shouldn't.
Wipes.
Wipes, baby wipes, being yeah, exactly. It flows into a big tank. Solid matter, the fecal matter essentially, settles to the bottom of the tank.
Now, does that always settle? Because there are, I don't know how to put this, but there are floaters, aren't there? And there are sinkers. And by the time they get here, are they all sinkers, basically?
So they're pretty much all sinkers. Yeah, so you don't, it's rare to see the fecal matter float, but you will get a sort of a film of fat. We call it scum. Not a very nice term, but it is full of energy.
I'm getting the whiff.
It may be smelly, but this is not waste. It's a treasure trove of magic ingredients. At this site, they turn sewage into concentrated phosphorus fertilizer. And no chemicals are involved. It's all done by bacteria.
And as the sewage flows through, it's becoming progressively more treated. So by the end here, as it flows over this weir, it is by then a mix of treated sewage, but with the bacteria still in it. There are bacteria called phosphate accumulating organisms that will take up phosphorus beyond their normal metabolic requirement as an energy store.
So they're storing it inside their cellular body.
Yep.
And then they're going that way. They're heading off somewhere. Is that right?
That's right. So then they go into the settlement tanks. The bacteria settle to the bottom. We pump away a portion of that sludge to those big concrete tanks you can see over there.
The phosphorus-rich bacterial sludge is spun in these centrifuges to remove the liquid, leaving behind what I'm told is called sludge cake.
So this is basically human manure, right?
Yeah.
This rich compost is perfectly safe to be spread directly onto agricultural land. But it's bulky and heavy, and so it's expensive to transport. The real magic comes from the liquid that was spun off in the centrifuge. It's distilled into a powder called struvite, a concentrated source of phosphorus, easy to bag up and transport. The perfect fertilizer.
This is it?
This is it. So this is struvite, or magnesium ammonium phosphate, mineral phosphate fertilizer.
It's ingenious, isn't it? People flush their loos, they think that's just waste, and actually you've recovered very valuable stuff.
Yeah. No, it's great, isn't it? Yeah. Where there's muck, there's brass.
Instead of digging phosphorus out of the ground, we can recycle it, the way nature does, and that way we'll never run out. So could recycling save all our superelements? If only it were that simple. Which brings me back to smartphones. The problem with recycling comes from their incredibly sophisticated design. Some of you are probably watching this program on a phone. We filmed it on a phone. Even the seemingly simple things that your phone does are really amazing. For instance, your phone knows which way up it is, doesn't it? That seems really simple, but actually, there's a tiny machine inside the phone working that out. It's called an accelerometer. And it's got moving parts that are smaller than the hair of a flea. And it detects the force of gravity. That's just incredible, isn't it? Our phones are so smart, but their lives are short. The average lifespan of a phone is just 2 years.
Has anyone here ever wondered exactly what happens to your phones if you send them off for recycling? Well, they get reconditioned if they're in good nick and resold, but if not, they share the same grisly fate. I'm going to wear ear defenders.
Old phones are shredded in industrial machines far bigger than this blender. Every day, thousands of phones in the UK alone end their lives in this way. And so almost all the precious indium used to make touchscreens ends up in landfill.
Well, that's pretty impressive. In the end, I'm afraid to say, ends up as dust. A sad end, don't you think?
And it's the same story for most superelements. Helium is so light it evades capture. The rhenium in jet engines is baked into an alloy with other metals that are hard to separate out. So yes, we need to get much, much better at recycling, but it's never going to be a perfect solution. Ultimately, we're going to need new sources of supply, and there's one option that could solve all our problems.
I'm going to just let you guys have a look at these.
Find some new rocks. All superelements come from rocks, but these ones are particularly special. They're packed full of them.
Hold the Star Trekian material.
Using a sci-fi looking X-ray gun, we can find out exactly what's in them.
Yeah, 9 seconds. Okay, so what we're getting here is iron coming out, cobalt, nickel, who mentioned that, and uranium, both used in radioactive reactors. And
we've counted 6 different elements, and the list is still rising.
Bismuth, calcium, titanium, arsenic, yttrium.
But there's a catch.
Spotted.
They come from outer space. These rocks are meteorites.
T-minus 1 minute and counting.
Most of the elements on our planet originated in space. They were forged in the Big Bang or in the hearts of stars. They became incorporated into our planet as it formed 4.5 billion years ago. And they found their way into the other planets and moons of our solar system, as well as countless billions of asteroids. There's almost an infinite supply of all the elements we could ever wish for in space. And the idea of extraterrestrial mining isn't as crazy as you might think. This is the surface of Mars. Actually, it's a warehouse in Stevenage. This accurate replica of the Martian surface is where space hardware destined for the Red Planet is put through its paces.
So welcome to our Mars yard. This is where we test all of our rovers that we're developing to go to the surface of Mars. They're going to launch in 2020, land in early 2021, and then drive around on the surface and take samples from a variety of different locations.
So you're going to pick up rocks on Mars?
The ultimate plan for this is to drill underneath the surface, collect a sample, see what elements are there, what minerals. Could it potentially have supported life is one of the big questions.
How feasible is it to go to another planet or to an asteroid and mine it?
There's lots of things that need to be developed to get us to that point, but this is one of those things. We're starting along that road now.
From this Stevenage warehouse, Airbus designed and built the Rosetta spacecraft that landed a probe on a comet in 2014. And in the workshop, they're developing the next generation of extraterrestrial robots. This space vacuum cleaner can sample alien soil.
We can start the brushes and you can see them rotating opposite to each other, and then it would go down into the surface like that, and you can see all the sample being flicked up into the inside of here.
So this is a prospecting device. You set it down onto an asteroid, you gather some up, and then you bring it back to Earth, see if it's valuable.
Yeah, pretty much. This is what's going to allow us to work out what's on there. Is it really of interest?
This technology is being developed for scientific missions, but it could one day be used for commercial ventures.
So are there companies seriously interested in mining in space?
Yeah, definitely. There's companies being set up, that have already been set up today, focused specifically on mining in space. You've also got governments around the world that are setting up the regulations that are going to be required to do this, allowing companies to go and mine on the moon or mine on asteroids.
This all sounds so incredible. I mean, how far off are we realistically from mining in space?
We'll be able to do it in the next 10 or 20 years or so.
20 years, so in my lifetime, we could be mining space?
Yeah, certainly.
NASA is planning a mission to a metal-rich asteroid in 2023. They have no intention of mining it, but if they did, the iron alone is estimated to be worth quadrillions of dollars. The trouble is, we don't have the technology to bring it back to Earth. And even if we did, it will probably cost more than the metal is worth. But if there's one thing history teaches us, when the demand is big enough, we tend to find a solution. Harnessing the astonishing powers of materials has built our modern world. With super elements at our fingertips,
Okay.
our creativity knows no bounds. We have made the world more advanced, more connected, and more exciting than ever before. But in doing so, we've also made ourselves vulnerable. By exploiting the amazing properties of elements that are becoming scarce, there is a danger that the technologies we take for granted will no longer be available. Ultimately, though, I place my faith in human ingenuity.
I'm optimistic that we can avoid running out of the very stuff on which we rely. Using better design, much more efficient recycling, and maybe even space mining, we can keep our material culture healthy without exhausting what the planet can provide.